And go. All right, guys, so last time we were together, we were talking about the difference between rotation and revolution. Quickly, what did I say? How do you remember rotation and what rotation is? What did I say? Everybody. Rotate 24 is great. Rotate 24 is great. One rotation is how long? 24 hours. Good. That is the Earth spinning, right? Then we say revolve, revolve around the sun. Just one orbit and the year is done. Awesome. Well, not only does the revolution around the world also help us to have our seasons, but it also has an effect on the weather. Okay? And so I'm sure you guys have seen, some weather forecasts. Today we're going to talk about what causes the weather and specifically about the water cycle. Now, if you'll remember, I've told you before that the same water that the dinosaurs were slobbering out of their mouths is the same water we're drinking today. So, hundreds and hundreds and hundreds of millions of years later, we are drinking and bathing in all the same water that we did back then. So what happened is that the Earth does something really cool. And what do so that water is always fresh? What do, Brian? Sure thing? You know you learned in 4th grade. What do?
Purify it?
Yes, but how does nature purify the water? Yes. It keeps going over and over.
Like the water cycle?
The water cycle. What would be an easy peasy lemon squeezy word for cycle? We have life cycles, we have the carbon dioxide cycle, we have the water cycle. All of them make a what? A circle. So circle and cycle are very close to the same thing, right? So when we have the water cycle, it's actually clean water. As a matter of fact, it's really cool. If you guys ever watched Survivor Man or Bear Grylls, that if you ever get caught somewhere without water, did you know that you can actually turn your urine into pure water? What? Yes, all you need to do is have a plastic covering, and whenever the water evaporates out of your urine and gets to the top and sits there and drops, are there any of the impurities in there? No, because a lot of those are solid, and so they don't evaporate. Remember, water will evaporate at as low as 0 degrees Celsius. So all that water that would be in little droplets above are actually going to be pure, clean water. Okay? So today we're going to make a little miniature weather system so that you guys can see how that works. If you are person number 1, I need you to come over here and fill up a sandwich baggie. Person 1. That's you. Come over here, fill a sandwich baggie with ice. Make sure you seal it very tightly. For person 2, you can come over here and get a beaker with warm water. It has to be about 2/3 full. Just use your hands, grab it, throw it in there. It's just water. All right. While we are waiting, okay, we're going to go ahead and do a fundamental. This is an interactive lesson about water in the air. Okay, is there water in the air around you right now?
Yes.
How come I can't see it?
Because
Wait, I'm asking one person at a time. Why can't I see the water that's all around me right now? Because it's what? It evaporates with gas. Are gases visible or invisible? Jennifer? Guys, let's take turns answering. Gases. oxygen, water vapor, nitrogen, carbon dioxide. Visible or invisible? Brian, I can't hear Jennifer. Invisible. Guys, all the gases in the atmosphere around us are invisible. So you're going to take your bag, kind of get it a little level. You're going to simply place it on top of the beaker, and we're just going to leave it there. And we're going to check back in on it in a little while. So make sure that it's not, you need to get all the air out of your bag. It's not hot water, it's warm water, right? Would you say that water is boiling? No, nowhere near boiling. It's just warm. We're just going to leave that there for now. All right, if you can, Brian, go turn off the lights for me, sweetie. Okay. So let's take a look at what is in our air. Okay? When I talk about air, that's kind of the way the second graders talk about it, right? Oh, the air. But what we call it here in fifth grade is the atmosphere, right? The atmosphere is the layer of gases around a planet or a moon. In our case, our atmosphere has lots of gases in it. Now, if you ask most people, what's the most abundant gas? Remember, if you have something in abundance, it means there's a whole bunch of it. What's the most abundant gas in the atmosphere? Most of them would say oxygen, but that's not true. Oxygen only accounts for 21%. 21% of our atmosphere. What is the most abundant gas is, what does it say? Nitrogen. How abundant is it? Well, let's see. 78%. Now you're going, I've never even heard of nitrogen before. Nitrogen is a very important gas. Problem is, animals cannot use nitrogen straight out of the air. The only way we can use it is if we eat it. So the plants and bacteria in the soil have to, quote unquote, fix the nitrogen for us so that we can use it. But we have a lot of nitrogen in us. Nitrogen is a very abundant gas in our bodies also. 78% nitrogen, 21% oxygen. How much does that leave for all the other gases together? 1%. 1 itty-bitty percent. In that 1 itty-bitty percent, we have carbon dioxide, we have water vapor, H2O, we have hydrogen, we have helium, we have argon, we have neon, any other gas. All of these together only make up 1 little percent. Okay? So we really have 21% oxygen, but still, that's plenty for us, right? We're all breathing, aren't we? Anybody not breathing today? Yeah, it's all working out for us, right? No pizza. Just hang on, man. Fun after this. There you go. All right. So, water vapor in the air is a gas just like nitrogen or hydrogen or oxygen. It is invisible. Where did it come from? It came from liquid water, and we're going to get to that in just a second. But how much of the water vapors in the air is what we call the humidity? What's the word? Humidity. Right, so sometimes in the summertime you come outside and it feels like the air is just sitting on you and it's heavy and kind of clammy and you're sweating like crazy. Ah, it's so humid today. You ever heard anybody say that? Yeah. That means there's a lot of water in the air. Okay? If there's a lot of water in the air, we say it's humid. If the air is mostly dry, we say that it's this word. Arid. Maybe you've heard of arid extra dry. It's an antiperspirant, keep you dry. Except they use it with 2 R's. Arid simply means dry air. Okay? Dry air. Now, there's a word over there you might not be familiar with. I'm going to write it up here.
Contain.
Well, you know what contains means. Dehumidify. You see this word in here? Humid. Remember I said that means lots of water, right? What happens when you put the prefix D in front of a word? If I am going to defund your bank account. If I am going to, yes, what do you think that means? Reverse. It means take out, right? So dehumidifier, guess what it takes out? What is this? Water in the air. Guess what a dehumidifier does? takes that water in the air. Okay? All right, so we have moist air, and moist is just another word for what, Lisbeth? Your inside of your mouth is moist. Some people have very moist skin. No, it's the opposite of dry. It means just a little wet. A little wet, okay? So moist air, and then two of these pictures are dry air. Jacob, why don't you come up and put one word where it belongs? Okay, Nelson, come and do another word. Okay, Van, come and do another word. I don't call on people who yell out at me. Okay, and Melanie, do the last one. You lost it. It's okay. Perfectamente. All right. So in the desert, it's very arid. That's because in order to be called a desert, it needs 10 inches or less of rain in a whole year. That's not a lot of water, is it? Okay? And also, this whole job of this guy is to dry up the air. But these two, what is this kind of cloudy looking stuff I'm looking at right now? What is that?
Is that fog?
It is. It's fog. But if I can see it, is it a gas?
No.
It's not. No, it's not smog because it's out. Look, it's out in the beautiful environment. It's not in the middle of the city. Smog has lots of ash from smoke and contaminants. This is all pure water. So if this is not a gas, is it a solid? Are there chunks of ice coming down it? No. So what's left? Water as a liquid. What? That's liquid. And you're saying, like, how is that liquid floating in the air? Same way that you are surrounded with solid skin cells floating all around you. Remember I said if you look up in the projector, stream of light, you see those teeny tiny little pieces of, wow, they're dead skin is what they are. Okay? Right? Can you see them when they're here? No. That's because they're teeny, teeny, tiny. But what happens when you put a lot of teeny, teeny, tiny things next to each other? I can't see one skin cell, but can I see my skin? Yeah, that's just a big collection of skin cells. Same thing with fog. Fog is a cloud on the ground. What's fog? A cloud on the ground. It is made of water droplets that are tiny, but once you have a whole bunch of them together, then it is visible to us, right? So water vapor is invisible. Liquid water droplets, like a cloud or fog, are visible, meaning I can see them. All right, so let's take a look at two situations. Both of these towels have the same amount of moisture in them, okay? In scenario 1, I'm just going to add heat to the room. In scenario 2, I want to add heat, but I'm going to add a pan of water. I'm going to tell you right now, this towel will dry in 1 hour. Based on your past experience, give me a good prediction. How long will it take this towel to dry? If this one takes an hour, how long do you think the second? How long, Jacob?
3 hours.
3 hours? Any other predictions? What do you think, man? 2 hours? 24. All right, go on up there, Brian. Hit go. First one's already dry. Are you sure? Oh, there went the 3 hours. There went the 4 hours. What? 10 hours. That is 10 times more time it took to dry that towel. What happened to the water level that was in the pot, Alexis? Yeah, the water level went down. That water evaporated. Does that mean the water is gone? No, we never lose water. We don't lose a drop of water or a drop of energy. If it's not gone, where is it now, Jacob? If it's not gone, where to go? It's not in here anymore. It's in the air. Can I see it? No, because water vapor is turned it invisible. All right. So this is all happening through a process that we call the water cycle, round and round. Vapor goes up and the rain comes down. Remember that song? Okay, great. All right. What do you think is the energy, the power source for the water cycle? I'll give you a hint. It's also power source for the life cycle, power source for the carbon dioxide cycle, power source for the nitrogen cycle. Yeah. Go and touch the sun. Click on that, son. Okay, is there any way Earth can make light? No, Earth cannot make light. We depend 100% on the sun for light, just like every other moon and every other planet. All right, so evaporation. Now here's the thing. What temperature does this water have to be in order to evaporate, Van? So you're telling me this water has to boil? Yes? No? Okay, let me show you what the temperature of the water would be in Fahrenheit to boil. 212 degrees Fahrenheit. Now, has it ever in your whole life been 212 degrees Fahrenheit outside?
Maybe. No.
Maybe. Okay, let me ask you this question. Your blood is made of almost all water. What would happen to your blood if you went outside and it was 212 degrees? Your blood would boil. We would be dead. The highest recorded temperature is about 130 degrees Fahrenheit, nowhere near 212. So how does water evaporate if it's not getting that hot? Yes?
It still evaporates.
Oh, so it can evaporate at a lower temperature than this. All right? Let me think. How low can the temperature be and water still evaporate?
130.
Okay? So that water doesn't evaporate otherwise, right? Okay. What do you think? Right?
40. 30. 40.
Okay, here you go.
Zero. Oh yeah, you said
0 degrees Celsius. 0 degrees Celsius, 3 things can happen to water. If it's 0 and goes down, water will freeze. If it's 0 and goes up, a solid can melt. And if it's 0 and goes up and it's a liquid, it can turn to a gas. It can even turn to a gas straight from below 0 degrees, but that's called sublimation and not evaporation. So you're saying, I don't believe you, Mr. Dierschke. If you don't believe me, I'm going to prove it to you. I want you to take a cup that you can mark a marker on, put water in it, not write the water level, and put it in the refrigerator. I will bet you $10 in 2 weeks, some of that water will be gone.
$5.
Okay? What? I can evaporate water in a refrigerator?
Yes.
Yes. Because is your refrigerator higher than 0 degrees Celsius? Yes. So you will be able to evaporate it even in there. So that's a common misconception, okay? You can evaporate water at any temperature. Yes.
If like water can evaporate in the refrigerator,
Yes.
how do all the other things and stuff?
They would, if you would give them a long enough period of time. Okay? But obviously it's going to evaporate faster at 70 degrees Celsius than it will at 0 degrees Celsius, right? Right. All right. So let's see. We have evaporation. Can I see this happening?
No.
No, evaporation. And what is the word right here in the middle of evaporation?
Vapor.
That's not, okay, that just says vapor. Have you ever heard that word, vapor? Me neither.
Vapor.
Vapor. So if you vaporize something, I have my little, what do you call that? Laser gun. Now your table is a gas. That's what vaporizing is, turning something into a gas. Okay, so vaporizing, water vapor. Ding. Okay, water vapor is an invisible process. Okay, so what is going to happen next is as the water vapor goes up, it's going to get into the atmosphere, which is colder than down here. Why is it colder? Because the earth and the water are good. They're good heat conductors. They let heat stay in there. Okay? And it's holding on to the heat. Air, not so much. Air can't hold on to heat very long. Okay? So down here, it's always going to be warmer than up here. If you're riding in an airplane, you open the door, you would get frostbite. Okay? So, up here, we have a cooler set of circumstances. When you cool a gas, it becomes a liquid. That is called Condensation. Condensation is the noun. Condense is the verb. It condenses. That makes what? Clouds. Condensation creates clouds. When the clouds get full, it's called what? What's going to happen now?
Rain.
It looks like it's going to rain. Okay? So, how does that happen? Jacob, can I borrow you for a second? You don't, I mean, it's 100% voluntary. Okay, so, all right, turn this way. All right, when you were little, your parents carried you around. Okay, honey, let's go. Let's go to the store, honey. Do they still do that? Why don't your parents carry you around like this anymore? Hey, Joe, why don't they carry you like that? You've grown, and now they're more likely to drop you, right? Guess what happened to the water droplets that were tiny? They blew up. Oh, and now they're too big. And I'm going to drop you, honey. Sorry, you weigh too much. Right? What is the force that's causing that, Lizette, that makes things... Gravity. Gravity is going to make it fall down. When the water moves from the sky to the ground, precipitation. Precipitation. Is it always liquid?
No.
Could also be what?
Hail.
Yes, it could be solid like hail or snow or ice or sleet, right? Okay. Then we have what's called runoff. And all it is the water is running off on the top surface, right? It can also, remember, pull sediments down. Gravel, sand, silt, clay. Gravel, sand, silt, clay. It can dump those sediments, deposition down here and make a delta, right? But pretty soon, it all comes back to where we started. Okay? When the rain comes down, does it only fill up lakes?
No.
No, it also goes into the ground. It goes into puddles, right? But guys, I just want you to remember, if I spit on this table and come back tomorrow, will that spit still be here?
No.
No. And did that spit ever have to boil to be gone into the air?
No.
Never had to boil. All right. So let me show you. Precipitation can be liquid or
Snow.
solid. It can be liquid or solid. All right. So I'm ready to do the investigation. If you can go turn on Margarita the light. Okay. All right. Michael, you and Matt will pass those out. Okay. Go ahead and open up your hand lens. Guys, as you can tell, these are brand new hand lenses. Have never been used by a human ever. So I want to get them back in the same condition that you have them now. Never been used by human hands. Okay, with your hand lens, I want you to, and again, try not to move it. You can stand up and go look. I want you to use your hand lens. I want you to look at the glass on the beaker that is between the top of the water and the bottom of the bag. I want you to look in that area. Use your hand lens. I want you to investigate what has happened on the glass between the top of the water, and the bottom of the ice. What is happening in that little area? Nope. Well, there's separation. Hey. All right. Can somebody tell me what you just made in your beaker? What I made? No, if it was water vapor, I couldn't see it. There is water vapor in there, but that's not the part you're seeing. What is the part you're seeing? Water droplets, so you just made your very own personal cloud. You just made your own baby cloud. Oh, that's so sweet. Are there parts of that baby cloud that have bigger drops than other parts? Take a look. You see that's a bigger part, that's a bigger drop, right? That's a bigger drop, okay? If you feel on the outside, I want you to notice, feel the outside of the glass where it's the water in, and then feel where the cloud is. Is there a change in temperature? Yes. Remember how I said you make a cloud? I said that the warm water vapor goes up, and when it gets to the cool atmosphere, it condenses back into water. So I cannot see evaporation going on, even though it is happening. All I can see is the condensation So is the outside of your beaker wet? No, that means all the water came from the inside. How did the water rise? It rose as a what? A liquid or a gas? Gas. Let me show you how that happens. All right. Remember, water molecules in solid form are close together, right? And they're only vibrating. As they warm up, they start to move around each other. That's a liquid. As you warm them up more, they start to move around faster. That's a gas, right? So when you all of a sudden make that gas cold, it comes back together, and then when it gets big and heavy enough, what happens? It comes down. So if you look at your beaker and you see some bigger drops, what do you predict is going to happen to them in the next few minutes? They're probably going to get pulled down by gravity. So I'm going to show you a simulation of what happens at the molecular level during evaporation and condensation. Okay? All right. Now this is neon. I'm going to change it to water. Okay. Water is H2O, right?
Yeah.
That means this part right here, the orange part is oxygen, and the two whites are hydrogen. So H2O, 2 hydrogen and 1 oxygen, and they are chemically bonded together. I cannot tear them apart. Okay? So, do you notice that they are vibrating, but they can't go around each other? Okay? As I cool it even farther, what's going to happen to their speed? They're going to slow down. What's going to happen to their proximity to each other, their distance? They're going to get closer. Okay? So here is ice, right? So this is a solid state. It could be snow if we're talking about precipitation, right? The cooler it is, the slower the molecules, right? If I add heat, they get excited, right? Heat, oh my goodness, that's so hot. Now it's liquid, it's moving around. As I continue to heat it, they're turning into gas, right? So here are some gas. Now notice there's a lid on this container. That's why the gas molecules are not leaving. But I want you to imagine this is water vapor. How am I going to make this back to liquid water?
Cool it down.
Cool it down. And as I cool it down, you're going to start to see they're getting, not only are they slowing down, but they're also going to get closer together.
They attach together.
So they like each other. They're very good at bonding with each other, which is why you can flow, because your surface tension, right? Okay. So you see how they're getting closer together now? And now they're going to start to freeze. So let me show you just really quickly. Solid water, liquid water, water vapor. Water vapor becomes a liquid when you have condensation. Liquid becomes a solid when you freeze. Solid becomes a liquid when you melt. Liquid becomes a gas when you evaporate. Gas becomes a liquid when you condensate. Okay? So, to get from a liquid to a gas, heat up. Gas to a liquid, cool down. So that's why I say heat liquid up, evaporation, cool gas down, condensation. Okay? If you think about the word condensation, what are the first 2 letters?
C-O and
Cool. CO, and cool is also CO. So that's how I remember condensation cooling, CO. All right. On the back of the bubble map I just gave you, I want you to draw the model that's in the middle of your table. I want you to draw and label it. I want you to draw and label what's in the beaker, what's on the glass, what's on the top. Okay? So here's my beautiful example. I'm not an artist. I've told you that many times. Okay? So hopefully some of you have more artistic talent than I do. Okay? But I want you to put what is going on at each stage. Now, I cannot see the evaporation. I can only see the condensation. So, again, when you use your hand lens, I want you to see that are all your drops the same size. They probably started off close to the same size, but what's happened? As more and more and more water molecules turn to droplets, then they get heavy. And so you might see little stripes. Where are those stripes coming from? That's where a water droplet ran away, right? It got pulled down by gravity. Okay? I also want you to talk about, no wonder yours is not covered up all the way. I also want you to talk about the difference in temperature. I want you to remember, if you haven't done it already, feel the side and then feel the side above it. Okay? Is this water anywhere near boiling? No, it's not even particularly hot, is it? It's barely even warm. Yet, it is still fully evaporating the water, and as the water hits the top of where this is representing what? The cold atmosphere, okay, it's going to go down. As soon as you're done with your drawing, this is what I want you to do. You may not have known it, but you just made some rain, okay? So you're going to be able to pick up your bag like this, and you're going to be able to look under and look at all that. See those big droplets? Rain, rain. Feel it. Yeah? Well, how did that get there? It got there because water from there evaporated, touched this, turned back into liquid water. So, heating it up to go up, evaporation, cooling it off, turning it back into drops, condensation. If you go out on the street and you ask 10 adults, are clouds mostly solid, liquid, or gas? I'll bet you how much, what are they going to say? They're all going to say gas. And you're going to say, are clouds invisible? And they're going to say no. And you're going to say, so how are they a gas? Right? Can you think of a gas that's not invisible? I want you to do this. Ask your friend to watch and ask them if they can see water vapor coming out of your hand, out of your mouth to your hand. Watch. Can you see it? Yet, what happens as soon as you touch your hand? Yeah. Can you feel it? Yeah. So water vapor's coming out. I just can't see it. How many of you, when you were getting out of the car, and this frigid, really cold air went like this? What was that white stuff?
Your hair. It's the warmth of your air.
Okay, the water vapor coming out of you was warm. Why did it turn white? Because you just turned it into water drops. You just made a cloud. That white part you can see when you're outside is condensation. If it's not condensation or solid ice, you cannot see water. You can only see it in liquid and in solid form. You cannot see water when it's in gas form. All right, turn your paper over. You guys should know by now a double bubble map is a way that we do similarities and differences. Similarity means things they have in common. Differences means things they do not have in common. So, I'm going to go ahead and put down, oops, here it is. I'm going to put what you need to write in each of the sections. Okay? So first of all, what do evaporation and condensation have in common? I'm going to turn this on just a second. Okay? The first thing is, they're both part of the water cycle, right? Remember the water cycle? Evaporation, condensation, precipitation, accumulation. So go ahead and write, they're both part of the water cycle. That's a commonality. That's a similarity. What do I mean when I say H2O?
Water.
It means they're both made of the same chemical formula of water. When I change water to a gas, does it become chocolate? No. When I change water to a solid, does it become soda? No. It has the same chemical formula, H2O, the whole time. Never changes. That's because what you're doing when you change states is only a physical physical change. Can I change ice back to liquid?
No. Yes.
I can't melt ice?
Yes.
Yes. Can I change liquid back into a solid?
No.
I can freeze?
Yes.
Yes. Can I change liquid into a gas?
Yes.
Yes. Evaporate. Can I change gas to a liquid?
Yes.
Yes. Condensate. So I change them back and forth, back and forth. Still water. It's not like when you have a chemical change, like I cannot unfry an egg, I cannot unburn a piece of paper, I cannot unrust a nail. Those are irreversible changes. That's when some new compound has been made and not the same. This stays the same. All right, moving to the left, we're going to see what is it that evaporation has that is different than condensation. Number one. Now, let me see if I can brighten this up a little bit. It's really dark for some reason. Is that better?
Yes.
Okay. In evaporation, a liquid, what? Becomes a gas. That's what evaporation, vaporation, evaporation. Okay? What makes a liquid evaporate?
Hot.
Caused by heating. We're on this side, baby. Oh, okay. All right, and what is the product? What is one of its characteristics? The product is invisible. It is invisible. Once something has evaporated, it is no longer able to be seen with the naked eye. You might be able to see it with specialized telescopes, listen to me, I am so off today, microscopes, but to the naked eye it's invisible. Okay, naked eye just means without a lens, without a telescope or a microscope or a hand lens. All right, on the other side, everything we just wrote here, we're going to write the opposite because condensation is the opposite of evaporation. Instead of a liquid becoming a gas, it's a gas becoming a liquid. Instead of being caused by heating, it's caused by cooling. And instead of having something invisible, it's something
Visible.
visible. That means I can see it.
Okay.
So it's 100% completely different. This is what I want. I had a really cool simulation and I can't seem to find it. Okay, here's a really cool picture that's taken by NASA. All right, if you have a specialized camera, they are actually able to see water vapor. So there's on one day. Okay, there's another day. So you see how it's what happens to it is the clouds move it around, right? And then as it cools off, it turns into clouds. As the clouds get heavy, then it turns into what? What happens when the clouds get too heavy? What happens when Jacob gets too heavy for me to carry? I drop him.
Well, you kind of let me down.
I know. I kind of did let you down. That's sad. Okay. Ooh, so look right here. You can see these areas have more water vapor in their air. That means they're going to have higher or lower humidity?
Higher.
Higher humidity. So where does it look like there's a lot of humidity? Anybody know where my hand is right here? I know it's in Texas, but what city is always humid? No, Dallas, honey, is way up here. That's Houston. You ever been to Houston? You walk off the airplane, you feel like you're being hit with a wall of water, except it's invisible. Okay, it's also very humid near the coastline, right? That would make sense. A new rule. Oh, that's just an